Welcome everyone. In this session, we are going to cover JavaScript number type and their useful methods. So what are waiting for? Let's start. Apart from the primitive number type, JavaScript also provides the number reference type. The number is a wrapper object allowing us to work with numerical values. A number object is created using the number constructor by passing a number value as an argument. For instance, where number object equals new of number, passing the parameter as 50. Here we defined a number object with a numeric value of 50. By make use of the value of method, we can achieve the primitive value out of a number object, that is console.log of num object dot value of. Now reload the page, got generated with the output representing the primitive value of the number object. Now let's have a look for the toString method. The toString method accepts an optional argument that determines the radix or base of the numerical value in which we want to represent the number. For instance, where count equals 45, console.log of count.toString. It will return a string representing number object in decimal format, that is 45. Console.log of count.toString passing parameter as 2. It will return a string representing the number object in binary form, that is 101101. Console.log of 255.toString passing parameter as 16. It will return a string representing the number object in hexadecimal form, that is FF. Now reload the page, got generated with the output representing the number object as a string in decimal, binary and hexadecimal form. But in real life, we often have values in units. For example, 100 pixel in CSS or $21 while dealing with the amount followed by the currency symbol. In this case, we need to extract a numeric value out of that, which can be easily resolved by the functions like parseInt and parseFloat. The function parseInt returns an integer and parseFloat returns a floating point number. For instance, console.log of parseInt of 100 pixel. This evaluates to 100. Console.log of parseFloat of $21.5. This evaluates to 21.5. Now reload page, got generated with the output represents an integer and floating point number from the string. Moving ahead, let's have a look for math, which is a built-in object that has properties and methods for mathematical constants and functions. For instance, console.log of math.flow of 15.8. This evaluates to 15 since it returns the largest integer less than or equal to a number. Console.log of math.ceil of 15.8. This evaluates to 16 since it returns the smallest integer greater than or equal to a number. Console.log of math.round of 15.8. This evaluates to 16 since it returns the nearest single precision float representation of a number. Console.log of math.trunc of 15.8. This evaluates to 15 since it removes everything after decimal point without rounding. Console.log of math.random. It returns a random number from 0 to 1 but not including 1. Console.log of math.max passing parameters 7, minus 10, 0. This evaluates to 7, that is the greatest from the arguments passed. Console.log of math.min, passing parameters 7, minus 10, 0. This evaluates to minus 10, that is the smallest from the arguments passed. Console.log of math.power, passing parameter 2, 10. This evaluates to 1024, that is, it returns the base 2 to the exponent power 10. Now reload page got generated with the output which represents mathematical operations performed on numbers using math built-in functions. Now let's have a look for the methods responsible for formatting numbers. ToFix method. This method rounds the number to n digits after decimal point and returns a string representation of the result. For instance, where numObject equals 56.78. Console.log of numObject.toFix method. This evaluates to 57. Here rounding happens and fraction part doesn't exist. Console.log of numObject.toFix method, passing 1 as parameter. This evaluates to 56.8. Here also rounding happens. Console.log of numObject.toFix method, passing 4 as parameter. This evaluates to 56.7800 by adding 2 extra zeros. Now reload page got generated with the output which represents formatting a number using fixed point notation. ToExponential method. This method formats a number in E notation. For instance, where x equals 70, y equals 7,89,000. Console.log of x.toExponential, console.log of y.toExponential. Now reload page got generated with the output which represents formatting a number using E notation, that is 7e plus 1 and 7.89e plus 5. ToPrecision method. This method returns a string representing the number object to the specified precision. For instance, where z equals 1.456. Console.log of z.toPrecision. This evaluates to 1.456. Console.log of z.toPrecision, passing parameter as 2. This evaluates to 1.5. Console.log of z.toPrecision, passing parameter as 1. This evaluates to 1. Now reload page got generated with the output which represents a number to the specified precision. Moving ahead, let's have a look for the differences between a number object and a primitive number. For instance, where numObject equals new of number, passing parameter as 10, where num equals 10. Let's have a check through type of operator. Console.log of type of numObject. This evaluates to object since numObject is a number object. Console.log of type of num. This evaluates to number since num is a primitive number. Now let's have a check through instance of operator. Console.log of numObject instance of number. This evaluates to true since numObject is a number object. Console.log of num instance of number. This evaluates to false since num is a primitive number. Now reload the page. Got generated with the output which represents the dissimilarity between a number object and a primitive number.